Good day, ladies and gentlemen, and welcome to lesson 4 of solving systems of equations. And today is going to be about solving what we used to call verbal systems of equations, which really should have been entitled word problems. And more specifically, when we talk about delta, we're talking about context questions. So context means with the text. In Spanish, the word con means with, and text obviously means written word. So this is with written or spoken word. We're going to be solving word problems in systems of equations. And to do that, we're going to employ a lot of the skills we learned in cancellation throughout the last two lessons. We're going to be trying to get additive inverse variable amounts. So we use the equations together somehow. We'll be able to solve for one variable, go back, solve for the other, and check our work. There are many word problems that show up with substitution. I'm going to have to work those into the mix because I don't really have a lot of good ones yet. We've actually done quite a few word problem style systems of equations so far. The only difference is that when we looked at equations like Brittany and Amanda selling the cookie dough for a fundraiser, I had already decoded the relationship for you and gotten the two expressions and or equations that we were going to use in our system. In today's work, you're going to have to decode the relationships by yourself and come up with the appropriate expressions and or equations. When you decode, it's important that you recall back when we did a mini unit, a little bridge unit on solving word problems, that it's important that you underline, circle, and star important information, that you actually extract the information out of the relationship so that you can see it a little more clearly. If all you're doing is staring at words on a page, chances are you're going to be confused. In years past, when we would have tests formally in school, if a student came up to my desk and said, I don't understand the question, and they hadn't decoded it, I would say, neither do I, and I would send them back to their seat, and they would have to decode. And most of the time, as they began to decode underline, circle, star, important information, they'd go, oh, now I get it. So you have to be an active learner. Once you decode the relationship, it's important that you write a let statement. And a let statement in mathematics is simply suggesting with that one word that this is what I'm thinking about everything that's happening in this question. The word let indicates all that phrasing. You want to identify any totals, which is often a good idea. So if you're not sure where to start when you write an equation, a good place to start is with the total if you have it. In most of the instances for writing systems of equations, our total may simply be the variable y. We want to check to see if we wrote the correct relationship. As we get into next week's work, we will move away from equations and we will see systems of inequality. So it's important that we pay attention to the actual phrasing because it won't always be when are they the same or equal. Sometimes it may be when is it greater than or equal to, or when is it less than or similarly written. We want to make sure we solve our relationships using correct algebraic steps and that our answer makes sense. If we're looking for the possible weight of a baby or the age of a person and we get negative amounts, that would be awkward. So we want to make sure that we have an appropriate, reasonable answer. And then we want to make a concluding statement to identify what we actually determine. Let's get started. And in question number 1, if I were underlining, circling, and starring important information, I might begin by recognizing that Jack bought 3 slices of cheese pizza as well as 4 slices of mushroom pizza for a total of $12.50. Grace had bought 3 slices of cheese pizza as well and only 2 slices of mushroom pizza, and her total was $8.50. And the question asks us to determine what is the cost of 1 slice of mushroom. So there are a lot of students that look at this and like, Tooch, I think I just get it. I think I can see what's going on here. Since the cheese is the same, it looks as though Jack bought 2 more slices of mushroom, and it looks as though he paid $4 more. So shouldn't 2 mushrooms simply be equal to $4? And wouldn't that mean that each mushroom slice is $2 a piece? So there's a lot of non-formal ways that students often think their way through this. And this is a great question because you can kind of see the answer non-formally, and then we can talk about what it would look like formally with a formula. With a formula, we'd often suggest that you should have a let statement to identify all the things you're thinking about or to organize your thoughts about the relationships or the word problem that we're working with. So after you write a let statement, it's important that you consider what's actually missing. And what's missing in this instances are the costs of the cheese pizza and the cost of the mushroom. The mushroom's the one we really want to figure out in just a moment, but it's important that we recognize that we don't know how much the cheese costs either. So we're going to let maybe X be the cost of a slice of cheese, or possibly C for cheese if you prefer, and Y be the cost of possibly mushroom. And it wouldn't be wrong if you wanted to use C for cheese in the context of the question or M for mushroom. That probably would be a little bit easier to follow. X and Y is kind of neat because we can immediately graph it, which we'll eventually do. C and M will also be easy to use as well for obvious reasons. It'll make it easier to interpret as we do our work. So there are 2 equations here. There's Jack. And Jack's equation would suggest that he's got 3 cheese pizzas and he's got 4 mushroom pizzas. And together they're $12.50. And we've got Grace, who also purchased 3 cheese, but only purchased 2 mushroom, and it's costing her $8.50. So in delta, they would suggest that if we're solving a system means more than one, we have to use the two equations together. And if both relationships are in what we call standard form, x and y are on the same side, by the way, these are linear because they're x to the first, it's just repeated addition. We're adding the cost of cheese and or mushroom over and over again. Because they're in standard form, we can treat this as one giant equation. And delta would suggest that you just simply have to subtract the bottom equation from the top, which is true. But I typically like to suggest that subtraction is the same as adding the opposite, and it's more powerful to get into the habit of transforming this into its inverse amount, one of the two equations. So we have the opposite of positive 3x's, negative 3x's. So my preference is to actually multiply one of the relationships by -1. It's really good practice. And if I were to do that, I could represent Grace as negative 3x minus 2y equals negative 850. And Jack would still remain 3x plus 4y equals 1250. And if I chose to interpret this as one big equation, and I was going to take the total of the algebraic expressions on the left and make that equal to the total of the numerical expressions on the right, I'd simply add them together. Since I created additive inverse x variables, when I add them together, positive 3x's and negative 3x's cancel, and I'm left with 2y's equal to $4. When I divide by 2 and I divide by 2, I find out that y, the cost of a mushroom pizza, is $2 using a formal process. And although you could have figured that out informally, it's important to understand that the formal process will get you much, much further. And there's a lot more complex relationships you'll be able to investigate in engineering and medicine and finance and in your world around you. So we want to be able to not only determine it informally, but really work on the more powerful process. Normally, after we solve for the first variable, we'd have to go back and solve for the second. But in this instance, they only wanted to know the cost of mushrooms, so it's not necessary to solve for x and check our work. If you take a look at the second relationship, ladies and gentlemen, we're told that the cost of 3 calculators and 4 markers is $26. Additionally, it suggests that 4 calculators and 6 markers is $38. And we're asked to find the price of each item and label our answer above. Since we don't know the price of either of the items, this is where we would want to organize our thoughts and set up a let statement. Typically, when we don't know an amount in mathematics, we call it x, so we could go with x and y for calculators and markers, but as I suggested a moment ago, you might want to use variables more appropriate or in the context of the question you're doing. So you might want to say, let C equal the cost of a calculator. And you might want to let M equal the cost of a marker. Because we don't know either of those costs, they'd have to be different. One would be C and one would be M, or one would be X and one would be Y. So as you decode the equations above, it's important that you recognize that we have 3 calculators and 4 markers equal to $26, and we have 4 calculators and 6 markers equal to $38. So although it sets up nicely because the variables are on the same side for cancellation, we can't immediately add it up. Please don't do this. If you just add it up the way it's written, what would happen is you'd get 7 C's and 10 M's equals 64, which isn't incorrect, but it's not helpful in solving the system of equations because we weren't able to cancel one of the variables out. So what we need to do is modify the relationship in such a way with correct algebraic steps that we're able to create additive inverse C coefficients or M coefficients. So if you're trying to solve for M and get C to cancel, you'd have to get inverse or opposite C coefficients. And you'd have to know that 3 and 4 divide into 12, they divide into 18, they divide into 24, and so forth. And you could multiply by any appropriate amount that would get 3 and 4, the coefficients of C, to be additive inverse quantities. You could also try and cancel the M's, and you can multiply by an amount that would get the M's to cancel. And 4 and 6 also divide into 12, and they divide into 24, and they divide into 32. So any of those quantities would be appropriate to get the M's to cancel. I'm going to focus on the C's right now because often that's a little bit easier if you just focus on the first variable. And if I try to get the C's to cancel, I'm going to have to multiply by an amount to make 3 C's into 12. So I'm going to choose to multiply the entire first equation by 4. Increasing the entire first equation by a factor of 4, it can be rewritten in an equivalent form as 12 C's plus 16 M's equals 80 and 24. I believe that's 104. And since I've been able to create positive 12 C's using correct algebraic steps with the first equation in an equivalent form, I need to get the second equation to be negative 12 C's, and that would require me to multiply by negative 3. Multiplying the entire second equation by negative 3 and bringing that down to my workspace with an organizational arrow so everybody can follow my work, I'm going to get negative 12 C's minus 18 M's is equal to, I believe that is 90 and 24. That looks like 114. And it would be negative. I could then treat it as one giant equation and take the sum of the algebraic expressions and make that equal to the sum of the numerical quantities. In this instance, positive 12c and negative 12c cancel. I'm left with negative 2m's equal to negative 10. I divide both expressions by negative 2, and I find out that the markers are $5 a piece. That is some wacky marker. Must be a Sharpie. Once you solve for m, ladies and gentlemen, you have to solve for c. So knowing that m equals 5, I've got to go back and I've got to pick one of the two equations. I usually pick the first one just so I can stay organized. It doesn't matter which one you pick, it's going to give you the same result. And I'm going to substitute in place of m as 5. So I'm going to have 5, and I'm going to rewrite the rest of the relationship around it. 3c's plus 4 times 5m's equals 26. 3c's plus 20 equals 26. Subtract out the $20 for the cost of 4 markers, and you're left with 3 calculators equals $6. Divide by 3, divide by 3, and the calculators come out to $2 a piece. So this must be like those single function one, those 4 function ones you get at like the dollar store. That's a really strange question, the way the calculators and the markers work out. Once you determine the cost of the calculus, ladies and gentlemen, the last thing you'd have to do is check your work. You want to check if it's actually true that the calculators are $2, because that is awful strange, and that the markers are 5. And you should always check in the second equation, or whichever equation you did not use to find the second variable. So for me, that is the 4c plus 6m equals 38. Substitute appropriately. You have 4 times 2 plus 6 times 5 should equal 38. You can just plug that into your calculator, and you do in fact get 38 equals 38, and we're happy with that work. Cool. Flip. Okay, so question number 3 suggests that tickets for a high school dance cost $2 each if you buy them in advance, and they cost $2 each if you buy them at the door. Those numbers are a little off. The question's a little old. It probably should have been something like $10 in advance and $15 at the door. But the point of the story is that they're trying to suggest to you that if you buy them in advance, you're going to get a discount. And the reason you're going to get a discount is because it's going to allow the people planning for the dance to set up appropriately. If 150 tickets were sold and $320 was collected, how many tickets were sold in advance and how many tickets were sold at the door? So that's what we don't know, and that's where our let statement is going to begin. You should try and practice writing a let statement. And it's not a bad idea to pause the video and say, okay, Tooch, if I'm missing the number of advance tickets and door tickets, I have an idea of how I might write that. Give it a shot. If you took the time to pause the video and you wrote your own let statement, yours might look like mine. I'm looking for the number of advance tickets, so I'll call that A. A equals number of advance tickets purchased. And D would equal the number of tickets bought at the door. So those are my 2 variables describing the 2 amounts I don't know. Once you set up your 2 variables appropriately, the next step would be to try and write the equations that describe the information in the question. Now this one's a little bit tricky because each sentence doesn't exactly translate perfectly to an equation. What we actually have here are 2 totals. We have a total of 150 and we have a total of $320. And if you're not sure where to start an equation, a good place to start is with the total. So the easiest thing might be to suggest that we know the total of 150. So 150 is the number of tickets sold. So that must be what happens when we add A and D together, the advance and the doors together. Once you have an equation representing the number of tickets sold, you need an equation representing the amount of money collected. Well, the amount of money collected was $320, and that was a result of $2 per advance ticket, so that would be 2 times A, and $2.50 per door ticket, and that would be $2.50 per D. And there's our system. Once you get a system of equations, the next step is to try and modify one or both of them so that you can get the variable, A variable, to cancel, either A or D. Here's what I've got. So I recognize that the system would be written as such, and I knew that I was going to have to modify one of those equations appropriately to cancel either A or D. If I were going to cancel D, I would need the opposite of $2.50. I would need negative $2.50. If I'm going to cancel A, I need the opposite of positive $2 per A ticket, negative $2. And that seems easier to me. So my preference would be to multiply the entire first equation by negative 2, which would look like this. You can multiply an equation by whatever you want, so long as you do it equally on both sides. That's just the multiplicative property of equality. We're going to get an equivalent form of that original first equation. It's just going to look different. And the looking different is going to be super helpful, because that's going to allow us to take the transformed first equation, equivalent to the original, along with the second, and you should use organizational hours to show where your work is going. And then we would be able to add together the new first equation with the original second to get our A's to cancel. And you should try and do that and see if you can find out the value of D. If you were to take the time to determine or solve for D, what you would get is this. There were 40 tickets sold at the door. Once we know the amount of tickets sold at the door, we have to go back and solve for the other variable, the amount of the tickets sold in advance. I like to use the first equation most often to find the second variable. You could use either one, but especially in this case, the first equation is much easier to work with than the second. So I'm going to substitute 40 in place of D. And when I substitute 40 in place of D, I'm going to rewrite the original first equation, substitute appropriately, and I'll subtract 40 from both expressions to determine that there were 110 advance tickets sold. The last thing I have to do is check my work. And in checking my work, I want to make sure that I have the appropriate solution. So I'm going to take A and D, which I believe are 110 and 40 respectively, and I'm going to substitute that into whatever equation I did not use to find the second variable, which often is the second equation, just the way that I typically try and solve my systems. When I substitute it appropriately, I'm just going to type into my calculator the expression on the right. If there were 110 door tickets, advance tickets sold at $2 a piece, that should have been $220. And $2.50 times 40 door tickets is another 100. Together, they make $320 collected for all the sales of tickets, which is correct. And I'm psyched about that. So question number 4 is similar. And I'm just going to present it, and then we'll go on to the last one and see if you're able to put the pieces together as best as possible. Tickets for a movie at Island Cinema cost $12 if purchased online and $10 if purchased at the theater. And that's a little odd because in this instance, they're actually charging you when you get less if you buy at the theater. So maybe you're getting charged a convenience fee of $2 because you're getting them in advance and you get to pick your seats. Sometimes they do that. They let you pick your seats in advance online, exactly where you want to sit. So maybe they're charging you a little more. If there were 20 tickets sold in total and $216 was paid for the tickets, how many tickets were sold online and how many were purchased at the theater? So what we're missing here is the number of tickets purchased, sold online, and the number purchased at the theater. You can make those any variables you want, but that's where we're going to begin. We need a let statement to describe what's missing, and we need to organize our thoughts. And we're missing the number of tickets sold online and the number of tickets sold in the theater. I chose to go with X and Y because we often do. Also, I didn't like O for online because that looks like a 0, and I thought that might get confusing. Once you set up your let statement, the next thing to do is to extract out the important information to write your equations. Now, again, this isn't as easy as the first page where each sentence represented an equation. Here you have the information mixed up a little bit. You've got your totals in the second sentence. You've got a total of 20 tickets, and you've got a total of $216. So it's going to require you to think a little bit. You've got to understand that we're going to need to set 20, the total, equal to the number of tickets sold, which in this case would be X plus Y. We'd also have to set up an equation to represent the total money collected, $216. And $216 would be a result of $12 per advance ticket and $10 per door ticket. Once you've done that, you'd want to modify one or both of the equations to create additive inverse, either x's or y's, it doesn't matter. I chose to multiply the first equation by -10. You don't need to copy this because we'll just follow along. And having modified the first equation appropriately, I was able to take the modified first equation equivalent to the original and add it to the second equation. Adding them together, treating them as a system, I took the total of the algebraic expressions and made it equal to the total of the numerical quantities. The variable y canceled, and I was able to solve for x, the number of tickets purchased online. Once I got x, I had to go back and get y. I substituted into the original first equation because that seemed easy enough to use, and I found out that there were 12 tickets purchased at the door, and I eventually checked my work. Is it true that 8 online tickets and 12 purchased at the door come out to $216? And it did. Okay, so lastly, it's a good idea to try and do one of these on your own. So I recommend that you read through number 5 along with me, and you try and get as far as you can without my help. Mr. Dulce went to Price Club and he bought 3 pretzels and 4 sodas for $6.75. His wife went the night before and she bought 2 pretzels and 1 soda for $3.25. Determine the cost of a pretzel and a soda. So we want to find out how much each item costs and we don't know. You should pause the video and see if you can come up with the 2 equations described in the word problem above, Mr. Dulce and his wife's purchases at Costco. And then you should see if you can set up an appropriate system and solve correctly. If you pause the video, ladies and gentlemen, my hope is that you have a let statement similar to mine. You may have used X and Y, but I chose to call the cost of a pretzel P, and I called the cost of a soda D. I then wrote 2 equations based on the context of the question, and I got that 3 P's plus 4 D's equals 675, and 2 P's plus 1 D equals 325. I needed to get inverse variable amounts, and I found it easier to get opposite D's because I knew the opposite of 4 drinks, positive 4D, would be negative 4D, so I chose to multiply the entire second equation by -4. There's an infinite number of ways to do this problem, And some of you may have chosen to multiply the first equation by, say, -2 to get -6p's, and then you might have chosen to multiply the second equation by +3, or you might have changed the actual signs around and done +2 and -3, and you could have canceled the p's, or any similarly appropriate mathematical process. For the way I did it, I was able to get inverse D quantities, and by doing that, I solved for the cost of a soda. When the D's canceled and I divided by -5, I found out that the soda cost $1.25. The pretzel, excuse me. Once I found out the cost of the pretzel, I substituted back to find the cost of a drink. If it was $1.25 per pretzel, I chose the first equation. I substituted $1.25 in place. I chose the second equation this time. So I chose the second equation to solve for the cost of a drink. I found out that 2 pretzels were $2.50, subtracted it out, and it determined that 1 drink was 75 cents. Once I had the cost of the pretzels and the drinks, I checked my work. Is it true, based on that information, if I substitute back into the first equation, that 3 pretzels and 4 drinks will in fact equal $6.75? Substituting appropriately, I was able to determine that the 3 pretzels were $3.75, the 4 drinks were $3, and together they made $6.75, and my system was solved appropriately. Ladies and gentlemen, this is the lesson on solving word problems with systems of equations, or as Delta will say, context problems. So context problems are going to force you to decode the information, set up a let statement to identify the missing variables that we're trying to solve for. You'll then have to read the question probably a second time and go through and determine an appropriate system of equations based on the information in the question. You'll have to modify to get one of the variables to cancel in your system using cancellation. In some instances, you will use substitution. We'll go over that in class. And once you get one variable, most often you're going to have to solve for the second and check your work. I hope it makes plenty of sense. I thank you for your time, and I'll see you in class. Take care.